All right, we're going to work on lesson 10.7 today, writing equations for circles. We're going to work with what's called like the standard form for the equation of a circle, or sometimes call it center radius form. We're going to take that form and look at what it means, what the parts all indicate in terms of helping us see the circle graphically, and then also answering some real basic questions and being able to write equations using that. So first of all, let's get right to it. We have a very simple equation. It represents an equation for a circle, and we say that the center is at the ordered pair HK and radius is R. So you can see in the drawing here, I have center at HK and I have radius R. Okay, the equation for a circle with those pieces of information, HK is a center, R is a radius, is this: the quantity of x minus h squared plus the quantity of y minus k squared equals r squared. Okay, so when we have a given radius of r and a given center of hk, we can plug it in this equation. Now, what this does is any xy ordered pair that when I substitute it in here makes this true, makes the left side equal the right side, then that point has to be on the circle. Okay, so this equation will generate and help us find any point we want to find along this circle. Okay, that's what it does. Now, like I said, it's also called the center radius form for obvious reasons. Just like we had when we were studying lines, we had point slope form or slope intercept form, which gave us the slope and the y-intercept. This is called center radius form because we know HK is the center and R, the base here of this number squared, R is the radius. Okay, so we're going to use this equation over and over again in different ways today. Practice writing it, working with it, and picking out the key components. Okay, so the first question here being asked, and these are the kinds of questions you're going to get tonight, is to write the equation for this circle over here, given in this case, I'm sorry, they don't give you the center. They actually give you just this diameter. Okay, what we have to do is we have to find the center and the radius in order to be able to write the equation. So that was part of that title right there. So let's say we want to write an equation that represents this circle in this drawing. Okay, well, we got to know two things. We got to know the center point and we got to know the radius. So this information given has to allow us to get that. So the first thing is we can find the center. The center is going to be the midpoint of the diameter. We know that LM is a diameter. So L to M goes across the circle and goes through the center. And we know that a diameter is 2 radii. So we know the center of LM is the center of the circle. So how do we find the midpoint of line segment LM? Well, the midpoint it's the average of the x's. So add up your x coordinates, divide by 2, and the average of the y's. Add up your y coordinates, divide by 2. The answer to those then are your points. So it's going to be x is -3 plus -3 divided by 2. Y's are going to be 6 plus -2 divided by 2. So we're going to get -6 divided by 2 and 4 divided by 2. So our center is at -3, 2. And I'm sure many of you have already had that figured out. Okay. But in this case, that's how we can do it most accurately. And that way we're not making a mistake in our assumptions. Okay. So we found the center first. Now we got to find the radius. Well, we know the radius is half the length of the diameter because it takes 2 radii to make a diameter. So since this diameter is vertical, we can just count it, right? Anytime it's vertical, horizontal, I should say, or vertical, we can just count. So if we count the distance from this point L to this point M, that's 8 units. So the radius has got to be 4. So I know the radius of this circle is 4. I know the center now is at -3, 2. So we need those two pieces of information to be able to write the equation for a circle. So we're going to take center at -3, 2. We're going to take radius at 4, and we're going to plug it into our basic standard form for a circle, which is x minus h squared plus y minus k squared quantities here equals r squared. So in place of h, we're going to put this -3. In place of k, we're going to put 2. And in place of r, we're going to plug in 4. Now notice that in this first parentheses, it's x minus -3 squared, y minus 2 squared equals 4 squared. Okay, really the only simplifying we're going to do is in this case where we get minus a negative, we're going to write that as x plus 3 squared. We're going to leave this as y minus 2 squared equals 16, 4 squared. That would be the equation, simplest form of the equation that we're going to work with right now. Okay, so that's the basic type of question you're going to get. Another example, it says write an equation for a circle who has a center at -3, -5, and it passes through the point 0, 0. So we're given a center of the circle and a point that it passes through. So what do we do with this information? Well, we're trying to write the equation, so we need to know two things, the center and the radius. Well, they tell us uh, the center. I'm going to find the radius here. All right. The radius, remember, any radii of a circle is the distance from the center to a point on the circle. And I have the center point and a point on the circle. So what I can do is use distance formula to find how far it is from the center to the point on the circle. And the answer to that then is the radius. So the distance from -3, -5 to 0, 0 would be the difference of the x's squared plus the difference of the y squared. So we're going to get -3 squared plus -5 squared. That's 9 plus 25. I'm going to leave it as a square root of 34. Leave it as a square root of 34. We'll work with that. All right. So we now know the radius of our circle is a square root of 34 because that's the distance from the center to a point on the circle. Okay. We already know the center, they tell us, is at -3, 5. I now found the radius to be the square root of 34. So I have all I need to write my equation. Okay, so it's x minus h squared plus y minus k squared equals r squared. In our case, our h is -3, our k is 5, and our r is the square root of 34. So plug them in. X minus -3, quantity squared, plus y minus, oop, that should have been a -5 there, guys. Y minus a -5 squared equals the square root of 34 squared. And hopefully you see now why I said leave it as the square root of 34. Because what happens when we square a square root? Well, those are inverses. They cancel each other. Okay, so our final answer is going to look like this. Again, anytime we got minus a negative, we're going to simplify. So x plus 3 squared plus y plus 5 squared equals 34. That's our final equation written for this circle. Now, one thing I want you to notice here is because this is always x minus h and y minus k, the numbers in the parentheses always come out as their opposites when you go to use them. For example, x plus 3, y plus 5. The actual number for the center is -3, -5. It's the opposites of those signs. Okay, and it will always go that way. So just a little heads up on that. All right, this one says write the equation for a circle centered at the origin and going through the point -11, 0. Okay, well, first of all, they said it was centered at the origin. The origin is the point 0, 0. So we know the center of our circle is 0, 0. Okay, now we got to find the radius. Well, we know the radius of a circle is the distance from the center to a point on the circle. So in our case, if our center here is at 0, 0, and the point on our circle is -11, 0, the distance from the center to the point on the circle is a case here where we can count because it's a horizontal distance, and the distance there is 11. So I now know the radius of my circle is 11. So write the equation for a circle that has a center at 0, 0 and a radius of 11. Well, there's h, there's k, there's r, right? So h is going to be 0, k is going to be 0, r is going to be 11. Simplify, x minus 0 is obviously x, y minus 0 is y. So our final answer here is x squared plus y squared equals 121. That equation right there represents this circle. Okay, it's all about finding the center, finding the radius, and plugging it in. Okay, another example of this style question. Um, this one's going to be a two-part question. So the first one is just like the last question. The center is at the origin, and it goes to the point -6, 0. So find the center. That's at 0, 0 because we said it went through the origin. Okay, find the radius. Well, from the center to the point -6, 0, similar to the last question, that's a horizontal distance we can count. The radius is going to be 6. There's h, there's k, so you know what's going to happen there, and there's the radius. Well, the equation for the circle now with the center 0, 0, radius 6 is x squared plus y squared equals 36. Okay. And refer back to the last question if you didn't quite get that, but it's the same process before. Obviously, our radius was different, which gave us a different answer. Now, the second part of this question is going to say this: determine whether or not each one of these ordered pairs would be on the circle of x squared plus y squared equals 36. So is the square root of 11 comma -1, is that ordered pair on the circle? Well, again, remember that I said the equation you get is going to tell you generate xy ordered pairs that are on the circle. So if they give me one, I'm just going to plug it in and see if it makes it true. If this makes it true, then that point's on the circle. If it's not true, it's not on the circle. So the square root of 11 squared is 11. -1 squared. -1 times -1 is +1. 11 plus 1 is 12. That does not equal 36. So, no, that point's not on the circle. Do your next one. 3 squared plus 0 squared is 36. 9 plus 0 is 36. 9 is not equal to 36. So, that's not on the circle. 0, -6. 0 squared plus -6 squared equals 36. Remember the grouping symbol here. That's so important, okay? So -6 squared means -6 times -6. That's going to give me 0 plus 36 equals 36, or 36 equals 36. That's true. So this point, 0, -6, is on this circle. Check the last one they give us here. 2 and the square root of 13. So 2 squared plus the square root of 13 squared. Okay, when you take the square root of 13 and square it, the square root gets canceled by the square. So you're going to get 4 plus 13 equals 36. 17 does not equal 36, so that point's not on the circle. So it's really simple to take an ordered pair and test it to see if it's on the circle or not. You plug that xy value into your equation and you see if it's true. All right, so that's how we go about those. Okay, the last thing you're going to look at tonight is what if you're given the equation and asked to pick out and graph some information. Okay, this is kind of what I referred to a second ago. So it said, here's the equation. You get to identify the radius and center and then graph it. Okay, so first of all, to find the center and the radius, we're going to compare this equation and make it look like the standard form equation. So standard form looks like this: x minus h squared plus y minus k squared equals r squared. So we need to get a minus sign between the x and the h, a minus sign between the y and the k, and we have to write this as a base number squared that equals the original. Okay? So what we're going to have to do is take our original equation and write it as x minus -4 squared. Minus a negative is the same as +4, but now I can see h is -4. Okay, I got to have x minus, whatever the number is h. Okay, y minus k, I didn't have to do anything here because there's already y minus 5. So our k is 5. And then, of course, for the radius here, 3 squared is equal to 9. So this has got to be 3 squared. Okay, so what we now know is our center is at -4, 5, and our radius is 3. It's the base number when it's squared, so the radius is 3. The second part of this is for you to graph it, and this is on Alex, and it's going to give you a graphing utility, and you're going to plot the center, and then you're going to tell them the radius, and we can just go, horizontal over 3 units, and then it'll rough in the circle for you. So you'll have some of these tonight to do. But you got to understand, you got to make it look like the original equation by getting minus signs in there and then pulling out whatever the number is after the minus sign for your center. And the radius is going to be the base number that's being squared to get the original. All right. All right. So that's the beginning part of equations of circles. I have homework for you tonight on these topics. It's just going to be you really working with that formula. Just you're going to be working over and over and over again, putting in values and seeing what you get.